Hi, my name's Lane Malula,
And I'm Kosay Hartman.
and we're talking about the 100-meter dash times between freshman and senior, and male versus female.
All right, so 100-meter dash times. Our question is, which gender improves the best? We posed a question about 100-meter dash times, and that the males tend to improve their time better than the females do, and that the females tend to plateau, whereas the males keep improving their time. So the null hypothesis is that genders improve equally, but the alternative hypothesis is that males improve more, whereas females tend to plateau.
So for selecting our data, we used a website called athletic.net, which gathers high school and middle school times that have been entered. And so we have 15 sets for the freshmen, male and female, and 15 sets for the senior, male and female. Now we randomized this by using the random digits page from table B, and we selected one number between 1 through 100, and from there we would go get our athletes and figure out the data.
So as you can see, here's the male 100-meter freshman versus senior times. Freshman is there, senior's over there. See some general improvement times, definitely.
Here are the female times for freshman versus senior. We again have freshman on this side and senior on that side, and there is still improvement, but we'll see how that plays out later on.
All right, so for the results, we used the alpha of 5% or 0.05. So for the female freshman data, the X bar was 13.286, whereas the female senior data, the X bar was 12.646. The male freshman data, the X bar was 12.118, and the male senior data, the X bar was 11.16333. Now the male freshman versus male senior, the X bar difference was 0.0956, whereas the female freshman versus senior, the X bar difference was 0.064. So as we can see a significant difference from the males' X bar difference time, whereas the females, and the p-value for the male freshman to male senior was 0.0002073, whereas the p-value for the female freshman to female senior was 0.000002866.
Now here we have some visual graphs of the improvement, and on this side we have males freshman versus senior. We see a slight decrease, or not a slight decrease, but an average decrease throughout the male freshman to senior. We've got a bar graph down here which shows the freshman time average and the senior time average, and we see a giant gap between the two, so it's marginal. Over here in the female, we see a similar decrease. However, we know by the numbers that it's not the same, it's less. And then we see the female freshman versus senior time, which there is a decrease, but
it's on 0.4.
But it's not, yeah, it's not quite as much as it is over here in the male version.
So the conclusion is, looking at the p-value and the x-bar differences, we can reject the null hypothesis and conclude that the female athletes tend to plateau as male athletes tend to improve as their time goes on in track.
Now, a summary, what we would change, we'd like to get a larger samples. So this could mean a whole multitude of things, as in just getting more people from the state, or as another thing we'd like to do is more inclusion of other states, because we pulled from Washington. And so we'd like to include more states into the sample, therefore making it bigger and safer of a data collection. So we chose freshman versus senior because it gives the most amount of time to improve, and in the end, it makes the differences more distinct. So it's more noticeable than it would be if you compared a freshman to a sophomore. Thank you. That's our presentation.
Thank you.